So let's do a small exercise in the physical ADMega 32. So here is a program for blinking LEDs. First, we initialized the stack pointer. Then we loaded the value of FF. That means all bits are 1, loaded in R16. Then stored the R16's value to DDR-C. DDR is a data direction register. It's an I/O register. It tells, we use DDR to indicate that whether the port's pins are input pins or output pins. So in this case, as we want the pins as output pins, we stored the all 1 values to the DDR-C. Then for a pattern, we loaded R20 with 5-5. So the 5-5 is in binary, it's 0, 1, 0, 1, 0, 1, 0, 1. So in the loop, first it complements the R20 register. So for first iteration, it becomes 1, 0, 1, 0, 1, 0, 1, 0. Then in out statement, the value of R20 is stored in port C. Then there is a delay function, and after the delay function is executed, the program comes here and it gets complemented. So the new value is here. So I have made the circuit accordingly. In the port C, 8 LEDs are connected from pin 0 to pin 7, and I have connected a USB ASP programmer to burn the chip. So to program the chip, I'm using a software called Extreme Burner. I will load the hex file first. So the project is selected and the hex file will be loaded into the software. Then I'll write the chip. As you can see, the program was uploaded into the microcontroller and the LEDs are blinking accordingly. So you can see the LEDs are blinking accordingly. Each phase is taking 250 milliseconds of delay, and then the values are complemented and again 250 milliseconds of delay. That's it for today. I will see you next time with another topic. Thanks for watching, everyone.